Going to go through a typical linear regression question. So here we've got some data about life expectancy and infant mortality rates. I've already put the data into the GDC, and notice that I have labeled the columns X and Y at the top. So when we have data, the first thing we should always do is to graph it. So to do that on the GDC, I'm going to add a new page to this document, add graphs, and then go to menu, graph entry, and scatter plot. We can then press the variable button, and because I named the variables, you'll see X and Y are both there, and therefore we can put them in like this. So the data has now been plotted, but we can't see it because of the axes. So the easiest way to do this is to go to Menu, Window Zoom, and Zoom Data, and then we can see the data. So question A, explain why a linear model may be appropriate. When we look at the graph, we can see that the points seem to lie approximately on a straight line. So because of that, we can now do the linear regression. So I'm going to go back to the first page. And remember, the equation of the least squares regression line means that we're using the GDC to calculate the linear regression. It's going to be linear because we've been asked for the regression line. So we go to Menu, Statistics, Stat Calculations, and Linear Regression. There are two options. I'm going to use the first one, mx plus b. If I press the right arrow, then I'll see the two variables that I've stored, and then I press the tab to go to the next one. Notice that the regression equation is going to be saved as f1, and the frequency list should be 1 because there's no frequency in this table. And the first result column, I need to make sure this is column C so that it doesn't overwrite the data which is in column A and B. So the GDC has calculated the linear regression equation, mx plus b, so the equation is y equals negative 0.377x plus 82.5, if we round it to 3 significant figures. Part C asks us to interpret the gradient of the line. So the gradient is negative 0.377. This means that as the infant mortality rate increases by 1, which would mean 1 more death per 1,000 births, the life expectancy decreases by 0.377. And it's a decrease because the gradient is negative. Part D asks us to find the value of Pearson's product moment correlation coefficient. This is the R value, so it's negative 0.969. The GDC has also given us R squared, which is called the coefficient of determination, but we only use this for nonlinear regression, for example, exponential, quadratic, power, etc. For linear regression, we use the R value, which is the correlation coefficient. We can see this is very close to negative 1, so there's a very strong negative correlation between the infant mortality rate and life expectancy. So as the infant mortality rate increases, the life expectancy decreases. Finally, we've been asked to find the residual for Albania. So the residual always means the actual value of y minus the predicted value of y. So we could just use the equation that we've written down and do negative 0.377 times 15.1, which is the x value for Albania, plus 82.5. But a more accurate way to do it would be to use the function that the GDC has stored. So if I add a new page, add a calculator page, if we go to variables, we'll see f1 is there. So if we do f1 of 15.1, this is going to substitute Albania's x value into our regression equation. We get 76.772, and therefore the residual is the actual y value, which was 77.2, minus this predicted y value. So we find that the residual for Albania is 0.428.